MIT YouTube は各週金曜日に更新しています。その他にもテーマを決めて不定期ですが更新しています。よろしくお願いします。こんにちは。三菱 UFJ インフォメーションテクノロジーの南です。今回はアトランタで開催されているレッドハットサミットにやってきました。いくつかセッションを用意しましたので見ていただければと思います。
皆様こんにちは。レッドハット三浦でございます。今回高橋さんをお迎えしてこちらアトランタで楽しくやってます。せっかくの機会なので、インタビュー形式でお話を伺って、東京の皆さんにも、東京に限らない社員の皆さんにも、現場の状況をお伝えしたいと思います。よろしくお願いします。
So my name is Dr. Richard Harmon. I lead our financial services business at Red Hat globally. I'm based in London, and I've been at Red Hat for about 5.5 years, but 30 years in financial services globally.
My name is Eric Rosenbaum. I serve as the Chief Technologist in the Global Financial Services practice. Been in Red Hat for about 6 years now. Prior to that, I spent about 25 years in financial services, both with big banks and serving as CIO, CTO for some fintech, equity, and FX shops. Nice to meet you.
三菱 UFJ インフォメーションテクノロジーの社長の高橋です。私たちは三菱 UFJ 銀行の IT システムを支えています。今日はどうぞよろしくお願いします。
お願いします。
From a business perspective, it's a universal challenge and a problem, and it's not just localized, right? There are global organizations, in some cases nation states, right, that try to commit ransomware and all kinds of activities, financial crime basically. What we're seeing globally is a heavy use of AI and automation to address the ability of responding to these in real time, and very sophisticated testing of systems against these sort of types of intrusions. At the same time, the regulators, the central banks and other financial service regulators globally see this as a top priority globally, and they collaborate globally on regulations, on capabilities and tools, as well as who are the criminal actors, right? So it's a global problem. I suspect Japan is probably better than many other countries, but it is a severe problem, and it's rapidly scaling because the criminals are also using AI and automation to scale their programs, particularly things like ransomware.
To build on what Richard said, it's important to move fast and safely. The hackers are obviously using automation, using AI. So how can banks be safe? And it's all about doing things more quickly with automation and doing it safely. The days of taking 60 days to patch your servers, that's no longer okay when things are being released, almost daily in terms of hacks. Are you signing your code? Are you making sure that the containers you run in production are digitally signed? That would prevent the risk from ransomware. Do you have a facility that can rebuild servers? So if you have a problem, you rebuild from golden source on a daily or weekly basis. That's what some of the top banks are doing today. So it's all about how do you move safely and fast in order to reduce your risk. It's never going to be zero, but the idea and the nice aspect of open source is that there's so many people that are looking at the code that you have a collective worldwide effort to understand where the vulnerabilities are and responsibly report them and resolve them on a real-time basis.
サイバーセキュリティの対応に対して予防と、それから起きた後の復旧をいかに早くするかと、両面あると思うんですけども、特に侵害された後の復旧を早くするという観点で、レッドハットのソリューションがレッドハットのソリューションにどういうことを我々期待していけるといいかということを教えてもらえますか。
Probably most of them will be.
So the recovery is super important because if there's an event, heaven forbid, you want to be able to recover quickly. And multiple ways you can go about this. One is, how do you automate the rebuilding of the servers? In English, we call it repaving of servers. So if you have a golden source, a golden image, and you can rebuild that server when there's an issue and do it in a fully automated way, that allows you to recover much more quickly. You also want to know that when you're pulling the source code or pulling the executables, where is that coming from? Is that a trusted source? How do you make sure that you know who it is? So if ransomware happens and somebody gets into your system and installs something or changes something, you have the ability to press a button, and in minutes or maybe an hour, you rebuild the entire system. So that's going to reduce your risk. And from a compliance point of view, from a regulator's point of view, when you show the regulator that I can recover, in an hour, and I do this every day, or I can do a DR test whenever I want, that makes you much more resilient as an organization and reduces your risk profile.
特にオンプレミスの環境で、いわゆる個別の従来型の基盤、それから仮想化された基盤、VM とかを使った仮想化された基盤、さらにコンテナベースの基盤、この3つの間で、特に仮想化された基盤とコンテナの基盤の間で、差はありますかと。
So, from a difference between a virtualization point of view and a container point of view, I would say both you can do the same types of things. Again, you can digitally sign your artifacts to make sure that what's running in production is only what you've approved, what you have built, what you know your people have built. Now, with containers, those pieces you're running are much smaller, and you have the ability to run different versions side by side. So I think it's easier with containers as opposed to monolithic, bigger pieces that typically run with virtual machines. So I think the job is easier with containers, I would argue.